The way, WebSocket is a slightly advanced concept on top of HTTP. So once you will go through this whole today's session, you will understand things much more better. If you haven't done any kind of networking before or HTTP before, today we're gonna touch through a couple of things that you will really like appreciate the concepts and ideas that we're gonna be talking about today. And WebSockets has application in such a niche market, and even the places where it is being used, it is like it's really when you want to extend your application with the features which is like far from common, this is where you use WebSocket. It has really unique use case in a lot of very niche set of use case, I would say, in the like really fast real-time streaming or real-time processing or real-time communication in general. And this is like on top of HTTP. So the capability of WebSockets are the point where it surpasses HTTP, the current HTTP protocol. So when your current HTTP protocol is not able to satisfy certain requirement for use case, this is where we're going to introduce this. Sending small updates, yes, it is. It really depends on use case. So we will go into that. Small update, yes, when server want to push update towards the your web browser or client. For an example, RSS feed, where when you sign up for RSS feed, you don't. I mean, server itself send you the update back. So sending an updates, it is one of the best thing they can do. And like if you are into like stock market, you remember like why so many high frequency trading servers are just residing next to New Jersey, because the stock market is in New York and they need data and update as soon as possible, so the computers can do high frequency training. They need to reduce the latency as well as possible, and just to reduce the latency, they put out their own servers really like next to the New York City, because even that distance is like more distance to them. They need to like walk on a milliseconds. Like that's where they have their edge. And when you have some network protocol which is like really faster than traditional HTTP, this is the use case where you're going to use this like really instant update, instant communications, and you get the message and you process them and deal with them. uh, Update without refreshing whole screen, yes. So socket message are like it's kind of a if you remember Ajax message, if you know about the Ajax are basically you don't want to refresh the whole page, you just want to ask server for that particular amount of piece of information data, so use Ajax for that. This is something similar to Ajax, yes, it is true. But in certain use case Ajax is better. WebSocket are have certain age, because Ajax is also on HTTP, and WebSocket will be helpful because Ajax is like the client has to initiate the communication once the connection is established. Like server never say that, hey, take this. It's always like, hey, client always asking for data and server always gives. So server is always like passively responding. He's not actively requesting. With the WebSocket, you can actively request or actively send data, even though client hasn't asked for it, or use case is such a way that client hasn't asked for it and you can still send the data. With HTTP, you always send like you always make a request and server always respond. So uh, uh, this is something called server push. That is the keyword for that. So that is something is possible with WebSocket. So in that context, yes, if you don't have to refresh the whole screen, you don't need to send the whole web page. You can just send the piece of message, and that we will demonstrate everything, so it will get clear much and more clear towards the end. Okay, guys, we are 13 people right now, and I'm gonna officially kick off today's meetup. Uh, Thank you very much for joining. Today we're gonna learn about a very niche and very unique use case on HTTP called WebSocket. WebSockets are basically communication protocol, and they are alternative in certain use case to HTTP. And the basic the use case or basic idea about WebSocket is for the real-time fast communication, bidirectional communications. So let's get into it. Few like housekeeping thing. You can ask questions. I have two screens, so I can see all the questions coming in, and I can respond likewise. Today's talk gonna be a lot of theories because WebSocket has. I need to put up the right context before I teach about doing anything with the WebSocket. So just like sit tight and like go through. We'll go through all these things. You don't need a lot of advanced knowledge on networking. We're gonna cover a lot of things from basics. So even first time you are seeing this HTTP and all these things, it will get clear end of the meetup, and that's about it. Okay, so content, standard introduction. Then we're going to talk about a network layer, which will help us understand how the communication happens over the network, and HTTP protocol, which is the protocol that people use for communication over internet majorly. Then we're going to talk about WebSocket, which will like HTTP discussion will lead up to why we need WebSocket, and then we'll jump to WebSocket. Finally, we will look into Flask WebSocket IO. So Flask has an extension that allows you to do WebSocket. So we'll look into that, and finally we'll try to build the chat app. Hopefully we'll be able to do that in 1.5 hours. Let's see how far we can go. Okay, so what is WebSocket? So WebSocket is a computer communication protocol. So it is a protocol that means set of guidance or some kind of specifications, or it's a protocol basically. It provides full duplex. So these keywords are important: full duplex and bidirectional over single TCP connections. So what is meaning by full duplex? Full duplex means communication can be start from any direction, and anyone can initiate the communication. So half duplex example, a famous example of walkie-talkie, where when one person is talking, the other person cannot talk, and he has to like let the person A to finish before person B starts talking. So half duplex, only one person can talk at a time. Full duplex, anyone can start talking at any time. Bidirectional means anyone can start communication. So party A can say that, hey, I want to talk, or party B can say I want to talk. There is no like party A always start the communication, party B always respond. That is not the case. This is the case of HTTP. In the WebSocket, anyone can start talking, anyone can start communication. Server can start communication, or client can start communication. So it's a bidirectional, and they both can talk at the same time. So that is why it is full duplex. This communication, when you're talking on a phone, it's a full duplex. Anyone can start talking, both can talk together, and that's a full duplex. So this is what WebSocket provides, and it's over single TCP connection. What is TCP connection? We'll get into that. But this is the advantage of WebSocket, and we will see why we need that and what is the problem with HTTP. Now, why is WebSocket? So what is the ideal use case for WebSocket? So two words: real-time communications. Whenever you require to do a real-time communications, WebSocket is one of those viable choice that you want to look at. And very famous applications: chat of course, and live search. So if you know about when you like type, you see this search box when you type A, and all the list of content that start with the A comes up. Let's say Facebook search. On Facebook search or LinkedIn search, when you type person's name, like in every character you see the list of response. So in every character there is like server is sending you list of people. So that is like real-time communication, live search, real-time data streaming. So I was talking about this use case of stock market high frequency trading, where you really want your data to be coming really fast, because the more faster you get the price, the more faster you can make decision, more faster you can make money. So real-time streaming, interactive web apps. So if you remember, when you open up any Google Doc and you are collaborating, and there are 5 people has opened the Google Doc, you can see those cursor telling that where everyone is like pointing at, or where everyone is on the dock, or on the top you can see these are all of them are online. So that feature is available through WebSocket. So WebSocket actually made that happen. WebSocket really blew people's mind when, if you remember, I mean, before like 2010, 11, when someone is typing a text, you can see this like small text saying that person is typing, like small, on the chat bot, or on your chat message, or on a Google. I think Google introduced this first on their Google Gtalk, Gchat, where someone is typing, it says like, hey, like the person X is typing. So that person X is typing, that information, that idea, that how you will know that person, the other person you're chatting with is right now typing, how it will come to you. So that happens through WebSocket. That is one of those use cases that came out of WebSocket. To do that with HTTP would be really tough, and we will not brainstorm right now, but we will see in future, like during the talk. But having that functionality was really made possible by WebSocket because of its really real-time communication strategy and low latency and low overhead and all that kind of good stuff. So that's why we need WebSocket. So before really deep dive into all this HTTP and WebSocket, let's look at internet and communication. How communication happens on the internet. We are going back like World War II time, DARPA time. The first internet network connection came up. So before I even go to this OSI model, let's talk about this. Before OSI, what was that? There was something called circuit switching network. Circuit switching network, if you remember those black and white movies, those World War time movies where people used to sit on, like, it's basically the communication for your cell phone networks or your telephone networks. So all those telephone networks where in really really early ages, when like bell telephone time, when someone call and that go to operator, and operator like kind of like pull the switch and put the switch and like do the switching of a circuit so that your call will transfer to the someone who is the other side of the call. Like the really really old age of first version of communication over some kind of wire communication, that was circuit switching. And that evolved, and now we have something called packet switching. Packet switching is on top of internet. So when internet was invented, the communication has to happen between two computers, and that whole communication is called packet switching, because we use packet data packets, and telephone used to be circuit switching. So let's come back to packet switching or our OSI layer. Now, communication, what communication basically require. If I want to talk to person B, we both need to have common language. What is common language? What is that? Let's say we are talking to English. Like if I know English, he knows English, we can talk. If I know English, he knows Spanish, I can't talk Spanish, he can't talk English, we cannot communicate. So that means we both have to understand and basically come to this idea that we have to set up the common protocol, common language, so we both can communicate. Similarly, all computers over the internet, they have to come to some kind of set of protocols, set of ideas, or set of language, so they can communicate and understand between each other. Because at the end, the message that gonna flow from person A to person B gonna be just a signal. It's just gonna be electronic, like spikes of one binary spikes of data, or it's a transfer of electricity basically. So from that elementary, like just 0 and 1, you have to build up your whole communication protocols. So that is how it started. To understand how two computers are talking, when you say open google.com, and that google.com that you type in browser go all the way down, broken down into as small as a small electronic ones and zero byte that transfer over the cable, and then at the Google, it reached to the Google server and again built up into the request, and finally Google understand what you're asking for, that hey, you are asking for this particular search, and then again Google send whole data, and like everything goes down, transfer into the electronic signal and come to you. So to understand the whole pipeline, how from this much abstract level to this much ground level the whole process happens, people have come together and put together this whole model which help you to understand how that whole happens. So what they basically done, the idea is let's build the layers, and each layer will abstract out for the other layer. So basically when you're typing, that comes to this 7 layer. OSI is one of those famous model to understand the internet and to understand the networks, basically not the internet network, I would say, to understand the network. And this is not the only one, there are other models too, but this is one of the most famous and most being used model out there. So if you see, there are 7 layers. Top is the application layer and bottom is physical layer. So physical layer abstract out all the communication of ones and zeros, and how to make sure that ones and zeros transfer from your physical location to that Google's physical location. All kind of algorithm, all kind of complexity, all kind of logistic, they that will be covered in physical layer. So when you talk about physical layer, physical layer will abstract out all these details, and data link layer will never have to worry about what is going below. So physical layer will talk about, or kind of like cover, people who work on physical layer, the only problem they're working on, if I receive 1 and 0, how I make sure that this 1 and 0 reach to the other end. So this is the abstraction they are only worry about. The person who is working at network layer or data link layer, he doesn't have to worry about when I'm writing a software, I need to also worry about how my data will go there. He doesn't have to worry. Network layer engineers, when they design certain things, they assume that everything works fine, because people who are working on a much lower layer, data link layer, physical layer, they have abstracted out those information for me. So I don't need to worry about them. The people who are working on those layer, they will worry about me. They will just give me nice libraries or nice infrastructure or nice hardware, and I just need to assume that this hardware will work. I don't care when I'm on network layer. I'm just connecting to switch, to physical switch with the cable, and I will assume that everything will work and those two switch will communicate. How those two switch communicate, what goes inside it, how data are being transferred, what happens if switch goes down. I don't need to worry about that, because the people who are working on physical layer, data link layer, they have all figured it out. That is their problem. They will just give me nice abstraction that, hey, this is the switch. Now you build on top of that, that how you want to how you want to design your network. So all these layers are basically building up an abstraction on top of abstractions. And when you're working on certain layer, you just assume that everything below is like for you, that it will just work fine. So physical layer works, as I told you, about physical infrastructure. Data link layer assume that all electricity is working fine, and they work on something called like Ethernet and switch, which is basically the routers, and like not exactly routers, but even before router, there are some other physical instrument that network devices use to, when the cable comes in, you have to plug cable somewhere to make it work. So that is data link layer. Network layer is where the packets are formed. Uh, Packets are basically like they have. So as I was talking about the design, like when I'm sending ones and zeros, so it has to mean something. So packets are basically predefined format of how it will look like. My first 4 bit will talk about what kind of packet it is. My next 3 bit will talk about what is the checksum, or what is the all the extra additional flags. So they have defined this like whole kind of format of how my single packet will look like, what are the different part of the packet. And when I pass on that pack, when I design this packet and pass on to next layer, it will just take the packet, convert into ones and zero, pass it through, and on the next computer, when they receive those signal, they will try to build up the packet again. So when it reaches to network layer, they will try to reconstruct the packet from 0 to 1 and understand what is going on. All your IP addresses are designed on network layer. So your IPv4, IPv6, how to assign them, what to assign them, who is responsible for what, all these things are taken care on the network layer. Transport layer has end-to-end communication protocols. So up until transport layer, everything else is a physical device. So everything else has been fleshed out in the hardware. So when you come to the transport layer, then we are talking about writing software, like on your computer, writing software on your computer. Everything below that is all about hardware, your switch, your routers, your cables, everything uh, that covers that will come below your transport layer. Now transport layer has two basic protocols, TCP and UDP. I'll just go very briefly what those are. So TCP is basically called reliable protocol. So there are all kind of algorithm, all kind of checksum, all kind of sanity check, all kind of like making sure that each and every packet reach to your destination well. All these kind of mechanism are then TCP. Of course, there are more mechanism. That means it will consume more energy and more effort, and like uh, there is more latency, because basically TCP will make sure that your data reach intake without any disruption from your computer to other person's computer. And because of that reliability and that reliability and consistency check, there is some overhead on top of that. So TCP is kind of slow. UDP is non-reliable in a way that UDP, they start the packet, they set up the destination, don't care about or don't worry about whether they reach or not. So UDP are unreliable because they don't verify, they don't configure, they don't resend the lost packet. They just send it and like forget it. Uh, when UDP is important, like when you're doing video conference call, missing 1 or 2 pixels will not make a too much difference. So that's why UDP is more important there. Plus UDP is faster because there is no reliability check. Now TCP on the other hand has to be like when you're sending, let's say a 500 MB executable file. If you miss just one bit, it will be unusable. So you can vary with the time, but you want the reliability that 500 MB file reach intake as it is, and nothing is lost. And if something is lost, it is recovered. If some packet is missed, the packets are resent, and the whole data, whole 500 data is like reached as it is. Nothing is lost on the way. Nothing is disrupted. Is once and zero. It can easily disrupt. So all those checks and balance and all those algorithms and all those parities and everything is there in TCP. So that is the use case for TCP UDP. Now, when you're talking about HTTP or when you're talking about WebSocket, they both work on TCP. So just to make sure that we are talking about the communication which is reliable. Now, when you are writing WebSocket, you don't worry about, hey, my packets are reaching their well or not, because it's abstract out for you. When you're writing your code on application layer, you just assume that, hey, this thing gonna use TCP as a transport layer, so it has all figured it out. I don't need to worry about reliability. It's a TCP. It's gonna be reliable. When I'm sent packet, it will be received there, and it will be only not received there when the other computer is down. But it will be not. But the disruption won't happen because the path from the current to server is disrupted, or something is distorted, or something is missing out. So when you are saying that TCP is reliable, and then session layer present is application layer. So finally is the application layer where you have this DNS, HTTP, and WebSockets, and we will be working on HTTP and WebSockets. So this is just to give you an overview about how internet works. You start with the application layer. When you say www.google.com, that is the application layer. You enter, your web browser will use HTTP protocol, and then your information will be broken down into small packets, into APIs, into TCP packets, into IP address, into physical location, into 1 and 0 bit. And from the other end, it will start from the bottom at the Google server. It will read the data from physical layer, try to recreate the frame, try to recreate the packet, try to see at the what layer TCP, UDP, what is the packet type, and all those things are built up. And finally, the whole 1.0 will be converted into, again, the HTTP request. So it will read the request and do processing. Hey, this guy is asking me for learn Python programming meetup group. So it will build the response and send it back. So this is how whole networking, whole communication works. This is important so we can understand going forward how things work here, basically to set the context here. So this is our OSI layer, our traditional packet switching network. And what we're trying to achieve here is use the HTTP to do the communication faster. So before we get into the HTTP, I want to showcase a couple of things about HTTP and how it works. So let me open our terminal. Hope you can see my terminal. Quick yes. Okay, cool. So what we're gonna do is we're gonna start a small HTTP server. Python -m for module, and simple HTTP server on port 8080. Anything. So this is starting HTTP server. Now HTTP server, when it starts, now let's talk to HTTP server and see how request and response works. So I'm going to open up my browser and going to type localhost 8080. And basically it is giving me a directory. So let's click on this inspect, which will tell us about, so we are not interested in content, we are interested in network. So let's look at the network. And let's come here first. So as you can see here that my server has received a request, and you can see here there is something called get. So get is one of those method on HTTP protocol, which is like, we'll see, like it tells that get me this content. It's one of those standard way to ask for data. Or when you simply write anything like google.com, facebook.com, by default it always go for get request. So this is the type of request called get. This slash actually means like home directory or like the code directory. So we are the server started here and we are asking for like the home directory or the same path. So this is like path. This is the first path slash, and let's say there would be any folder inside this directory. Let's say meetup. So it will say slash meetup, and then it will go into slash meetup folder. So this is basically you are at a root or home, and the more directory you traverse, the more you can see the path changing here. Anyways, now see what this says. It says HTTP. That means this protocol is HTTP and then 1.1. This 1.1 is a version. So HTTP has different versions, and starting from 0.9, right now it is 1.1, and in future the 2 is up and coming, not supported by all the browsers, but 1.1 is right now famous, widely used, widely available, most reliable, and supported by every browser and everything. So 1.1 is the current version of the HTTP that being used. And 200 is a status code, which basically says that everything went well, like your request was okay, and I'm saying like it was okay. So this will change. You'll see what is HTTP status codes are. Basically, it tells that how your request went. Did it got accepted? Was that wrong request? Was there something missing? Did server fell down on a request? All these kind of different scenarios will be communicated through different status code. But simply when you say get and everything works fine, you get 200, which says that yes, everything works fine, like it's okay. So status code 200 is like yes, done, good, nothing went wrong. Now let's see the whole thing on the browser side. So if you open up the inspect from right click, you can see the inspect. I think all the Chrome and Google, Mozilla might also have them, or any other browser you're using for. All of them have one or the other way of looking at this tab. And there is one thing called network. And you can basically see all your web communications happening through browser here. So I'm going to refresh this page to like track the request. So let's just look at what our request is. So this is a request, localhost, and let's look at this part, which is called header. So basically, this is the request that we made. You can see the preview. You can see the response, timing, how much time it took, like queuing, scheduling, request sent, and how much time it took to content download and stuff like that. Cookies to like what it has been stored. Let's come here and see at the important part. So first thing is request. So what you are requesting. So request URL. So you can see the request URL here. You can see the method that we used to make the request. Status code, which says 200 okay, everything went well. Remote address. So this was the server address. So this is what it tells. And let's also like the request header. So this was like request URL in general. Now let's look at the header. Header is metadata or like some extra informations. So when you type this path, you also send some extra information about yourself to the server. And many of those metadata or extra informations are inside the header. So first thing is accept. So header. So when you're making the request to the server, your HTTP server, it says that what you are willing to accept, what is the connection, keep alive. Just keep an eye on this one. We're gonna talk in detail about keep alive. Caching, language, encoding, cookies, host, user agent. User agent is basically your browser. It's a Mozilla, although it's a Chrome, but don't worry about too much about that. But it says Chrome here. So this is a user agent. So this is basically this is the header, which has all this content that you set along with your request. Now let's look at the response. So you send the request and you got the response. And this is the response header. So when server send you back the page, so along with that content of the response, it also sends the content like the response header. So what response header has? First thing you want to look at is the content type. So it says text and HTML. So in the request, you say that, hey, I will take text and HTML. I will take application XML. I will take application XML and all these things. And so you say that I'm open to take any of this kind of formats. And finally, the response that you get was the text and HTML. The date and server. So you can see what is server says, simple HTTP 0.6 and Python 2.7. So this is the server that sends the response. So if you are using something else, you may get Nginx or Apache server or all those web servers or versions of web servers out there that people have deployed for the purpose of basically starting a server. Use the simplest minimalistic something that Python provide. You can use something else, but this is just to look at the content and see what happens here and how things look at here. Again, the eye on this get and eye on this status code. So one interesting thing I want to show you, like, so basically, so this was another get request, and if you see here, when I'm asking for slash, there is no, it's sending me the whole like directory path because there is no index HTML file. Let's create an HTML file and see what happens. So by default, whenever your web browser, when you do get request and when you have web browser, it always look for this index.html file in your web browser, in your host directory. And as soon as it's find index.html, it will just send index.html. You don't need to tell them that give me index.html. So I'm going to create index.html, and I'm going to create another one called hello.html. So there are two files right now here. Now let's go to a web browser and just do the refresh. So see, I'm not asking anything. It's just a slash part, right? And it has loaded the index.html file. You can see it is index.html because we wrote hi in index.html. So by default, your web browser will try to serve index.html always. If you don't find index.html, it will just throw the directory. It will just show you the directory. Now if you want hello.html, what is the other one? Yes, hello.html. So we say hello.html, and you can see here the request is made for hello.html. This is a request, response, and all that good stuff that we already looked at it here before, and you can see hello. So just to like give you an example of this is all HTTP communication protocol. We are using HTTP here. There's a method. There's a standards of like, hey, when you are making HTTP request, this is all has to be included. This is how I'm going to communicate. This is what I'm going to send in my header. This is what going to come into my response. So request response format, everything. So this all has been standardized, lined up, and all the softwares out there who are providing you HTTP server or client are implementing those protocols or those ideas, those concepts, those requirements. So because of that, you can do all these things. So someone I forgot to organize, and they have pinned down and laid out all the standards, protocols, and all these specifications. And your Chrome browser implementing those specifications. Your Python client, Python server is implementing those specifications, and that's why you see all these request response, all these contents are being added. So it's all based on agreed upon and decided communication protocols and communication standards, and basically a language. Because of that, this communication happens. So now we know that all this HTTP we have got used to it. So how it all started. So the first ever HTTP protocol was designed by Tim Berners-Lee. I hope you know Tim Berners-Lee. What extra information can be sent in header. So there are some default information that goes into header. If you have some advanced networking tools or even simply some kind of, you can basically send any information that you want in your header. You can have your own extra information. Your header is basically key value pairs or like a dictionary or it just like kind of like key and value basically. So there are certain key and value pairs which is like expected because that is how your server understand your request. If you don't provide those key and value pairs, then your server will just say, hey, I don't understand your request. And if you want to add extra information in your header, you can do that. But so there are some default that you must put. If you don't do that, it will reject. And then extra information that you can add for your for processing your application. If you have your custom needs for extra header information, you can do that. One of the use cases on the header, custom header is like we have this idea where, hey, do you want to download a CSV file or do you want to download a JSON file? And you can provide the custom header to say that, hey, give me the CSV file. And so your request is going to be same, give me file like /download, but based on the header, whether you specify CSV or HTML or JSON, you will get the response differently. So all that you can do basically setting the header. A lot of people also set header for the authentication. So you can add the authentication information in the header and stuff like that. Okay. So let's jump back to HTTP again. So who started HTTP? Who first designed HTTP? Tim Berners-Lee. Everyone knows Tim Berners-Lee. Of course, you should know Tim Berners-Lee. He's the guy who invented www, World Wide Web, Internet. Right now, sitting professor at MIT. So the first version was very simple. It only had one GET request, and there were no headers. And every time you make a request, so basically when you make a request, your HTTP protocol kicks in, and like HTTP protocol open up the request or open up the communication channel. Then you ask something, your server give you something, and then the whole communication channel is closed. So connection is closed as soon as your request has been received. So which was like the first version of HTTP. You say, give me the file. So give me file 1, communication happens, communication open up. You say, give me file 1, server will give back you file 1, communication closed. You say, give me the file too. Again, new communication starts open. All these things happen before establishing communication, authentication, everything. Then you ask for the file, server give you the file, and the channel is closed. So it was like every time you request for something, for every single request, a new communication channel is open up with TCP, and it is being closed and open up again for the next request. And it only had get method and nothing else. So this was like the first version, something that was like that to get working. It only supported HTML, so no fancy XML, CSV, anything. It will just send you simple plain HTML or text content, no crazy content. There was not even a content header itself, so it was not expecting you to like send different content, all those things. So the idea is something minimalistic that can work over the internet. That was the HTTP 0.9 designed by Tim Berners-Lee. Now after success of 0.9 or seeing the lot of good use case, there comes 1.0, which extend the 0.9. That means more capabilities in 0.9, starting with the idea of header. So before that, there was no concept of header in your HTTP protocol. They introduced the concept of header. They introduced request response, content type. There were different methods introduced: get, head, and post. So with these different methods, you can do different things. But again, the connection was also like getting closed as soon as the request has been served. So you make like, give me one file. As soon as a server send back the file, the connection is closed, and then you have to reconnect and make the connection open again for the next file or next content. Let's say you are serving a website which has 5 files. There are like CSS file, there are JavaScript file, and there's an HTML file. So normally when for every 3 file, for every of those file, they re-establish connection, ask for file, return the file, connection close, connection open, ask for the JavaScript file, return the JavaScript file, connection close. So you can see that like there's so much overhead going on. You can just open the connection once, send everything, ask everything, send everything, connection close. You don't have to go through opening and closing connection all the time, which is like overhead. It's like like every time you open the Chrome browser, you say google.com, search one thing, and once your search is like one search, tab close, open the browser again, type something. Once it is done, browser close. Like keep opening and closing browser for every single fucking request. So that is what happens in background on HTTP 1.0 basically. That so this was all overhead, limitations on very limited number of methods. Header was introduced, but it has some limitations and stuff like that. But again, it is a work in progress, and as 1.1.0 was very successful, so there comes 1.1, which is currently being used everywhere. Extension of 1.0. You have now get, head, post, put, delete, trace, option, all this kind of method. Because of these methods, different methods, RESTful design has been possible, because REST design REST design was afterthought. When they see that, hey, HTTP can do different kind of get, post, put, delete thing, I can use those different methods as my way of REST design, where I have object or resource, and I can do get as a request for the object, post as in create the object, put update the object, delete the object. That is the REST. So because of all this method, REST is possible. Very important thing, connection keep alive. So if you remember before, I was talking about every time you make a connection, connection get closed, and every time for the new file you have to remake the connection. But now because of this new new specification called connection keep alive, now you can keep the connection open and alive. Like you can open the connection, do all kind of transaction of asking or returning multiple files, and then finally close the connection. So that is a new thing, a more update, plus all the security performance. So you can see all the caching and cookies and stuff like that. That was all introduced in 1.0, and that is what being widely used right now. Now let's get slightly technical into how HTTP works. So when I was talking about why there is a overhead of opening and closing connection, because every time you open the connection, you have to do something called three-way handshake protocol. Three-way handshake protocol is basically establishing your connection from client to server. So what happens? First thing first, your server starts. As soon as server starts, server get into something called listen mode, and when it is into listen mode, it is basically actively available to take the request. From your client side, when you start an HTTP connection, the first thing client do is send you something called connect request, which is basically a sync message. Now this sync message is very specific message. it is the packet that has some standards and some kind of like a formatting of a frame, which is, so sync packet has some kind of flags and some kind of design, and like, hey, this whole packet gonna be a 20 byte packet. In this 20 byte, the first 4 byte will be all this XYZ flag, next 3 byte gonna be all this. So all these standards has been defined of how the packet will look like and what the format of packet is. So when you say, so you don't worry about that, you just say connect, and all this packaging information are taken care of or designed by your lower level your network protocol and TCP protocol, transport layer protocol and network layer protocol engineers. They design all these things, so you don't need to worry about it. You're working on application layer. You just say connect, and you say send me the sync packet, and what is the sync packet is, how it will work, how server will interpret. All those low level informations are figured out by the people who are working and designing the system, middleware, hardware, whatever on network and transport layer. You don't worry about that. Anyways, you send the sync package, your server sent you sync and acknowledgement package, and you can send acknowledgement package. So basically making sure that, hey, you say server hi, server say, hey, I hear you, and server say, yes, I'm ready to talk to you. So basically to make sure that client and server are ready to communicate. They both accept, client and server both accept the request to talk to each other, and now they are ready to talk to each other. So this is a three-way handshake protocol where you can see that there is like networking, like there are three, your packet is traveling 3 times, like you're going to from your computer to other computer, from other computer to your computer. So there's some overhead, there's a communication going on here. Message being passed and received, and so this is the three-way handshake that happens every time you make the HTTP connections. Now what happens? So this one, so the first one you see on your left is your HTTP 1.0, where your connection is closed. Connection is closed means for every request and response, you have to do TCP handshake. And on HTTP 1.1, which you see on the right, which has keep alive, which means you only do your TCP handshake once and then you do tear down. So as you can see here, in the older default HTTP 1.0 protocol, you do handshake, and then get it. You make the request, you get the response, then you say, I want to close the connection. You close the connection. Then again for the next file, you make another TCP handshake. You do again get request and response, and again you tear down the connection. So you see that every time you have to do the TCP handshake and TCP tear down for every freaking single request. But if you see here, in the case when you can do keep alive, your connection stays open. So your server, so you do only TCP handshake once, then all these get, and like all these requests and response happens, and finally you tear down the connections. Now one thing to note here, that request is always initiated by your client. So when TCP handshake happens, so here in the both cases, whenever TCP handshake happens, after TCP handshake, when they both agree that, hey, we are happy to communicate with each other, server never initiate the connection. Server never says that, hey, here is what I want, or here is what you should do. It's always client. Client is the first person after TCP handshake to start the communication. This is integral part of HTTP. So this is one of the limitations. This is one of those thing about HTTP, that after handshake, client has to make the first request and server only do the response. So server is only passively responding and client is always actively asking. So this is where HTTP, this is how HTTP works. You can say it's limitation, you can say it's a trade-off, or this is the mechanism of HTTP. And when you come to certain use case where after establishing connection, you want server to send, let's say, feed update, like that is not directly possible, or like server cannot basically start the communication after the TCP connection has been established. So that is the limitation of HTTP. And when you have use case where after establishing this connection, you want server to initiate the connections, HTTP will not work for you, and WebSocket will help you there. Anyways, just to like look at these two pictures, understanding how keep alive is important. By the way, keep alive also has a timeout. So it's not always keep alive, because when you keep the connection open, server has to hold some memory. Server has, so let's say you have this server which has 500 GB of memory. In the 500 GB of memory, it can, let's say 1 lakh connection at a time it can keep in the memory, because all this connection open, it has to hold the connection. Holding a connection means it has to keep certain things into the memory to make sure that it understands that like this connection is open. Basically the process is open. So when you keep alive, you can't just keep connection alive forever, because server can just so much keep connection open within its capacity. And because of that, after some time, when things get inactive, server automatically close the connection. So keep alive also has the timeout. And when there is no communication going on, when server don't see any message from the client after the last, let's say after last response, and 600 second has been left, but the server has not requested anything yet, sorry, client has not requested anything yet, so server will just initiate the TCP teardown and close the connection. So keep alive also come with the timeout. That is what I'm trying to say. And if your server stay inactive, your your client stay inactive, your server will close the connection. So this is what the capabilities that we have right now as a HTTP 1.1. Now, the use case that we have is we want to do something called real-time server update. What do I mean by real-time server update? Imagine this scenario. You are doing group chat. Now, what is a group chat? Basically, you have a server and there are 5-6 clients or 5-6 friends who are connected to server to do the, do the chatting. Server is the center place which is providing the mechanism for all these friends to communicate or talk. So as soon as so right now your server is, let's say you have 5 friends, so your server is holding 5 open connections with HTTP keep alive 1.0. Your friend one send the data to your server. So that has been one event happen on the server, that one person has requested to send the data to all the other people, all the other 4 friends. Now this is a server event. Now server is sitting on this data, but unless and until, because it's the HTTP, unless and until any of those 4 people or any of those 4 clients doesn't say that, hey server, give me data, server cannot send the data. As I told you, server cannot push the data to the client on HTTP 1.1. So client has to ask for data. So when your person one, your friend one, say that make a request, hey server, this is the data that I want to give it to all my friends. So your friend one initialize the request, get request or post request, whatever you want to call it. He initialize the request. He put the request to server. Server say that, hey, I hear you. I have your data that you want to share with your friend. And then we send the acknowledgement response saying that, hey, I got your data that I have to send to your friend. Now server is sitting on the data. Server cannot push that data to all the 4 clients because server cannot initialize the connection. So all those 4 people, they have to initialize the connection, ask to server, hey server, do you have some new data for us? So the way, if you want to design this kind of chat connection where one person is writing some content and that content is reaching to server and server has to push that content to all the other people, that cannot happen. And if you want to make that happen, what you have to do, you have to make the continuous communication or continuous get request to server. So what happens in this scenario? All your friends are continuously talking to server and continuously making the get request. Hey, did you receive something new? So basically the idea is, as soon as someone puts something on the server, any friend of yours send the data to your server, all your friends gonna keep actively listening or keep actively asking to the server, hey, did you got something? Hey, anyone send you something? Like keep asking. So this is something called polling. So polling is the idea where you continue keep on checking on something. That is the concept, that is the idea of polling. So you can do HTTP polling where all your friends or all your people or all the clients are actively pinging the server and actively and continuously asking for data. So to do this real-time server update, this real-time chat update, you need to use something called polling. And how the polling works. So basically, in the polling, you use something called keep alive. So this whole idea of connection keep alive is what make this polling possible, because you want to keep the connection alive until the data comes to you. Now there are 2 kind of keep alive connections or keep alive thing using the polling, something called short polling and long polling. Short polling is idea that on every freaking second, I'm going to keep asking or keep pinging server about new data. So imagine 5 friends continuously sending the get request on every second to the server asking that, hey, did anyone send something? Did anyone send something? Did anyone send something? So imagine the amount of processing and amount of network traffic that you generate when all of your friends are continuously hammering server, so that to know that if any of those friends have put something on the server for others to look at. So that is a short polling. So of course you can see the disadvantage that it creates a lot of traffic, it creates a lot of processing, because every time you make a get request, server has to process the request, server has to understand what what it is, who it is, how it is. It has to do all this pre-processing to understand that GET request. So it's all a lot of processing and all lot of like traffic generated at the HTTP with HTTP sort polling. So sort polling is not that ideal use case or that ideal way you want to put up the mechanism for doing this group chat. So what alternative we have? So instead of doing this sort polling where our timeout is just 1 millisecond, why not we do long polling? In the long polling, we just keep the connection for long time, like for the like say 5 minutes. Like I'm gonna open up the connection for 5 minutes and make the GET request, and then I will not turn down the connection. I will wait for freaking 5 full minutes and before I turn down. So for this 5 minutes, so server doesn't has to process this multiple GET requests now, because in the single GET request, it has to wait for 5 minutes. Let's say 5 minutes is the time when until someone send back some kind of message. So it has to like open up till like 5 minutes and then close the connection. Now you can see one scenario clearly here that server has to still hold the connection for full 5 minutes, basically. That means uh, everyone make a GET, and then server has to keep holding that connection until someone respond. So you are eliminating this idea of processing multiple GET requests because you are just holding one GET request. But again, you are still holding a GET request, and you still are waiting. And like, let's say there are 100 people joining the chat, 100 GET request you're holding on until and until someone make the request. And as soon as someone make request, you send the response, because everyone's GET request has been satisfied, because server now is broadcasting that single message to all those GET requests, broadcasting them, so everyone get the response as this one text sent by one friend to all of them. And then they're again making the GET request. And like, it's the basically idea is holding up a lot of memory uh, with this long polling. And there are also some synchronous problems. You will see some message coming before, some message coming later, and all that kind of crazy stuff. So you can see here that one request go to server and client is waiting for the response to come. So they're like, they wait for a very, very long time, and server hold the request open until the data is available. You are notified with no delay when the server event happens. So whenever server delay happens, it just send you back because your GET request is already open. Now this is more complex, and again, server require more resources because it has to hold those GET connection open all the time. So that's why this HTTP 1.1, with using which you can actually achieve this real-time, server or real-time chat thing, but it's not ideal because it has to do continuous polling. Now, forget about the polling of chat. Think about collaboration database. You have this Google Doc. 5 people are continuously looking at Google Doc and try to talk or try to communicate or like try to type things. So every time one single change happens, or even you don't even need to make a change, just to make sure that, just to tell all the other people who are looking at that dog that what the other 4 people are, you have to continuously send the request saying that, hey, all these 4 people who are online are sitting at that particular character, that particular line all the time. So just imagine that because client are the only, they have to generate the connection, server cannot push the data. So client has to always keep the connection alive, because if client doesn't keep the connection alive, if client doesn't keep asking server, client will never know if something else happened at the other end, because server cannot push the data by itself. It can always just a response, it cannot request. And because of that, all these applications of interactive collaborative is not possible. It is possible, but it's just so much ineffective, so much resource intensive, and so much traffic being generated just to like do this kind of interactive or collaborative multi user application that you're trying to work on, because of all this network traffic and all this GET and all this server has to keep all this connection open. Just so much resource traffic and so much complexity and so much craziness going on here. So because of that, HTTP 1.1 polling is not an ideal use case for that. Now HTTP 2.0 is coming in future. It has all these kind of benefits. Maybe HTTP 2.0 will get rid of this requirement of using WebSocket, but I'm talking about the time of 2010, 2011, or slightly before that, when HTTP 2.0 came in after 2015. So well before that, when we had all this problem, there was no better solution, and you were onto WebSockets. So once HTTP 2.0 is out, but it is not widely supported, because as you saw recently, I opened up my simple Python server, and it was looking at 1.1, HTTP 1.1 and not 2.0. So 2.0 is still not available widely, but it will be available. It has all this advantage of multiplexing, single HTTP connections, server push, which I was talking about, server actually send the data, not client has to start. All these things are there in HTTP 2.0, header compression, all this funny and great stuff. But until this one becomes widely available, if you want to do certain things, WebSocket is, we are still on mercy of WebSocket. Now let's come to WebSocket. What is WebSocket is? Finally, to the WebSocket. We are done with HTTP thing. So again, so let's look at WebSocket. So what happens with WebSocket? So of course, WebSocket is basically upgrade on HTTP. What does mean by upgrade on HTTP? So when you want to do WebSocket, what you do, you start your HTTP connections and you do the handshake. And during the handshake, HTTP 1.1 has this thing called upgrade, like keep alive, content type. There is one more header it has, it's called upgrade, which is basically asking for, hey, I want to upgrade this 1.1 HTTP connection to either HTTP 2.2 or WebSocket. So WebSocket is basically upgrade. So you start with your normal HTTP 1.1, and in your first HTTP 1.1 request, you ask server, hey server, let's move to WebSocket or let's move to 2.0, whatever is provided in your upgrade, and let's move our communication from HTTP 1.1 to this upgrade version. And your server says that, hey, I support your this new version that you're talking about. Uh, so 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 I support this upgrade that you're asking for. So let's upgrade. So basically, there is another status code we will see when we look at status code, which says that there is something called 101, which is reserved for HTTP upgrade. And when the server accept your upgrade request, instead of 2.2, it requests 101, and then you see that one single connection, and we can see all communication going to one connection. That we will see in the browser. Likewise, with what we saw before. So basically, you open the connection, it's a bi-directional message and anyone can open the connection. So anyone can start talking, anyone can start the first message. Once the handshake is done, server can push the content, client can push the content, anyone can make the request, anyone can do the response. So it's all bi-directional and full duplex. Bi-directional means client and server both can start the request. Server can also do the first thing. Not client always has to start the get. Server can also start. So server can push the data, or client can push data. It's bi-directional. It's full duplex. That means when one person send the data, the other person doesn't has to wait and response. So anyone can, I can send 5 requests while 3 requests are coming from the server. So it's always like we are talking. When we are talking on a phone, anyone can start talking and anyone can send the data, right? And both can talk overlappingly each other. So similarly here also, both can overlappingly send the message to each other and both will understand response. And it all happens on single TCP. So this is what HTTP provide. Now, if you see here, there's no get, post, put, all these things. So you cannot do REST with this because all those there's no caching here. There's no other fancy HTTP extra security and stuff like that it provides. WebSocket do work with HTTPS, or it's called WebSocket Secure, WSS. All security is there, but still there are so many functionalities that HTTP has that WebSocket doesn't has. But on the other side, WebSocket can provide you this bidirectional full duplex communication channel on single HTTP that HTTP cannot provide. So just quickly look at the pros and cons. So when you're doing WebSocket, full duplex bidirectional, as we talked about, it is best for two-way communication and real-time collaborations. And cons. So what is the issue with the WebSocket? So first thing, when you're doing WebSocket, it is basically upgrade on HTTP. So you need to do a bit of setup. So you need to configure your load balancer and proxy properly to make sure that your WebSocket requests are handled properly. It's difficult to horizontally scale. What does it mean by horizontally scale? So if you know about the concept of load balancing, now WebSockets are stateful, and because of they are stateful, they bring a lot of issues. Because when you're stateful, so let's say when you are stateful, that means your server who start the communication, he has to keep the communication all the time. What does that mean? So in case of real world scenarios, when you have, let's say, you have this HTTP server, RESTful API server, you can start 5 HTTP server, and your load balancer can redirect your message to any of those servers, any of those 5 servers. Your client can start the first request and talk to server 1, and then his next request, load balance can divert to server 5, because your request 1 and request 5 are independent. They both can redirect and communicate well, and nothing will break. But because in the case of WebSocket, because it has to be tied with only one connection, so every time you're talking with your client, your WebSocket, your load balancer or your proxy has to make sure that when there's a WebSocket connection, if the connection established with server 1, my load balancer should not redirect, even though on the load, should not redirect my connection to server 5. It has always redirect to connection my server 1. So because of that, you have to make some changes into your proxy server, which says that, hey, once this is the WebSocket connection, and this WebSocket connection has been established with this client 1 with the server 1. So all future connection and all future requests has to only go to connect server 1 from client 1, and it should not go to somewhere else. I should not redirect the second thing that client 1 sent to my server 5, because all the context, all the ideas are staying with the server 1 and not with the server 5. So there is no caching. So all these issues are there with the WebSockets. But if you can overcome all these things, and if your use case really match with all these things, then WebSocket could be really a win. As I told you, that you cannot really achieve that someone is typing subtext in your chat box. That is very critical or very crazy to achieve using HTTP, but very easy to achieve with WebSocket. So you see the advantage there, but there are some disadvantages. You just have to make sure that you're well aware of that. And right now, so many resources are available, so it's not like it's hard. You can still do that, but just be mindful that WebSockets are stateful, and that brings a slightly complexity in configuring your load balancer and proxy server. So that's a con of using WebSockets. Now we know what it is, how it is. Now jump back to how we can use and how we can implement. Welcome back to Python programming. Finally, after 1 hour, we are jumping to actual Python programming. So inside the Python, WebSockets are available. So there are native way to do WebSocket. Basically, these are like independent WebSocket library, which is like low-level APIs that you can do. The first one, the famous one, is WebSocket client. It is slightly low-level API, so you have to type more code and set more things than the ones that we have latest recently. The advantage is WebSocket client is supports Python 2 and 3, so you can use any of them. And when it comes to WebSocket, the WebSocket is another recent one, which has less number of complexity, more abstraction, and less code that you have to type to keep doing your WebSocket connections. But it only supports Python 3. So these are the native libraries. Now, apart from native libraries, we have so many web frameworks in Python, and all this web framework has also started supporting Flask, WebSocket connections. So Flask is one of those favorite that I use a lot, and Flask has two of those famous extension on the Flask. You have to add this extension extra or install extra library to add the support for WebSockets. But Sockets and Sockets.io, these are the two ones. Sockets are like pure WebSockets. So if your client, if your server, or if let's say either your web browser or your server doesn't support WebSocket protocol, then it will fail. There are very few who doesn't still support WebSocket, but you can't go ahead with the connection because it will fail. Flask Socket.io has this idea that, hey, if my browser doesn't support WebSocket, I'm gonna like set back on HTTP polling. So it's kind of like piggybacking or like a fallout or rainy day concept there. If I'm using Socket.io to doing my WebSocket thing, then Flask Socket.io will make sure that if the browser that I'm talking to doesn't support WebSocket, then it will fall back to HTTP and do all the HTTP polling. Now again, I do not worry about HTTP polling and how it has to handle and what it has to be done. It is all done by the down layer network protocols and Socket AI implementation. I just do my WebSocket style coding, and if something doesn't work for my browser, it will just take care of all these things. Django is another very famous framework. Twisted is another async programming framework. So all of them also has different kind of supports and additional package that you can install to do the WebSocket programming. So this is all the landscape I can show you right now that is available on Python if you want to do WebSocket, implement the WebSocket right now. Now, we're gonna get down into WebSocket.io. This is what we're gonna learn. And now WebSocket.io, before like we do the actual coding, I'm gonna go through some of the theories in the WebSocket. Now onwards, we're gonna focus on this WebSocket Flask WebSocket.io library and just follow through this. So WebSocket.io is basically the protocol where like a Flask application, you start the Flask applications, and then for every server, so what you do, you define server events. Server events are basically events on which so what basically what is basically server events. So think about the previous use case. All your friends, they want to send the message to each other, and there's a server who is a mediator, or who is kind of like distributor of the message when someone drop the message to server. So every time someone says that, hey, I want to send the message to all my friends, so that is the event. So your friend one is initializing an event, and this event says that, hey, send everything to my other friends. So this is the event. And now you can have multiple events. So you can define these events, and every time you are using the WebSocket based connection, so your client that is initializing this WebSocket communications, so his first WebSocket message will be tied to these events. So when he's sending this WebSocket message or WebSocket message to server, it will tell that, hey, I want to trigger this event, and this is my message or my text or my content. So how it happens? So normally in the Flask Socket IO, you initialize your Flask Socket app, and then you use this decorator called socket io.on. Socket io.on. Socket IO is basically, we will see in the code, we are basically doing the like initializing the basically Socket IO instance. And once you initialize the Socket IO instance, basically you start your Socket IO server. You say WebSocket IO.on message. So .on is basically tells that, hey, this is the wrapper around this method, and here you write the event. Now there are now you can define your custom event, and basically there are like there are 4 reserved keywords for the event. Message, JSON. Message is basically when you're sending the string. JSON is when you're basically sending this JSON. Connect and disconnect are basically for that. Connection, reconnection. Let's do one thing. Let's start writing the code, and let's understand why writing the code. That will make more sense. Otherwise, this will just make very fuzzy and very abstract. So let me fire up my PyCharm and create new project, pure Python project. We will call it Meetup 7, I think. I forgot. Anyways, interpreter, I'm starting a virtual environment with Python 2.7. This should work. And okay. So we will look into, so let me just easily set it up. Okay, so here. Okay, cool. So we will look through different ideas, concept, and keep typing to see the results and see how things work. Now, again, there's a request, there's a response. So basically we need a server and we need a client. What we are going to use as a client. So we will be using the server, but for the client, we'll be using JavaScript. So JavaScript, there is a famous JavaScript library called socket.io. We will use socket.io as a client in our communication because everyone will be logging through web page. So, it makes sense. Please bear with me. I don't think the event will be ending at the 8. We will see how quickly and how I will try my best to finish it before 8:15, but let's see how far it goes. Come on. So basically, your web browser or your JavaScript library will send the request, a WebSocket message request, and it will specify the event. And then basically on that event, you will basically react or respond or do something with that. In our case, let's say that one person who want to send the message, he will send the message specifying. So based on event, what kind of event is specified, it will work. So if he specify message, we are expecting the message that he's sending will be of a type text. If he's specifying his request, his WebSocket request with the event JSON, we'll be expecting that the message will come as in the form of JSON. And so as I told you, message and JSON are reserved events. So basically when message comes, it's always text. When JSON comes, it's always JSON. But when you have custom events, so you can specify something called my event, and then with the my event, you can specify any of those different data type, and you have to then know that what data type you will be your client will be sending, so you can process likewise. And so here what we are just printing the request. Now it can have only one data in your request, or it can have multiple data. So you can also send set up the like a tuple of data in your single request, single WebSocket request, and then you can process them and catch them and do things with that basically. So this is all about how our server or client, whoever is receiving the request. Basically, it is listening on some of the events, and when it listen to some of when it's actively listening on some of the events, it will like do the processing when request comes in. Now there is something called namespace. So when you're making all these requests, so namespace is basically like a when you're setting up a WebSocket, you can basically set up the path, and this path is called namespace. Likewise, when you do HTTP requests, you say that, hey, like slash Python programming or meetup slash something slash something. So very similar concept. You can have namespace, and when you're sending the request, if you don't specify namespace, your default namespace is gonna be only slash or home or root, and because of that, so it's a default is slash. So everyone is who is sending the data to my event will be actually attached to that namespace. So when you are sending, so here you are receiving the request, so you are receiving the message on this namespace, and even when you send the namespace, you have to send the message, you have to look into the namespace. Now you can also do callback. What is the meaning of callback? So if you see here, when the request came in, we didn't do anything. We just server just sit on the request and like process it and just print it on his side. But if you want to tell client that, hey, I received a request, you can do something called return. After return, it could be text, it could be function. You can write the callback function here, which will send something data. But every time request comes in, you can do some kind of return, and this return will be a callback, and that will send the acknowledgement response to your client, and he will know that, or he will receive some kind of message based on your response basically. So this is all about receiving the message. So you know that if you want to receive the message, if client has to receive the message, if server has to receive the message, first thing first, it has to set up its own something called event listener, and you have to define the event and set up the event listener. Event listener is designed by this decorator with the socket.io app that you instantiate by .on, and then you wrap the method around. So method will basically act on whenever some request comes in. When you receive the message on this event, this is what your server has to act on or do on or work on basically. So this is all about receiving the message. Now let's talk about sending the message. Again, anyone can send message, either client or server, doesn't matter, but this is how you send the message. So basically with the Flask, there are two methods that you can use to send the message. So this is how you listen to message, and this is how you have to actually call this method to send the message. So for the sending, so there are unnamed events and there are named events. So what are unnamed events? So message, JSON, connect, disconnect, these are called unnamed events. Basically, because they are like reserved keywords and reserved and default events, you can say. So when you are dealing with this kind of events, you say send. When you are doing something custom, when you have your own custom event like this, and you want to act on something, you want to send request, which is doing my event, you use emit. So using emit, you can actually make the request to this method. But if you want to send the request to message or JSON, you have to basically use send. We will see when we see the code, we will see. Oh God, this is taking so much time. Okay. Now, so sending the message. So what we're gonna do here is, here is the code where your server or client, whoever, as soon as it receives some kind of message, it just like throw back the same message back to the sender. So here you can see that here my server is listening on this event called message, and as soon as it receives this event, it will send back the same message again. Now see here, I'm using send, I'm using message, and I'm not providing any event name here. Why? Because this is tied to, I'm sending it back to the server or client who send me on this reserved keyword. because here is the message, because socket.io on message, I'm using send and message, and I'm not adding anything else. Here it is my event, because it is my event, because it is non-reserved keyword, because it is custom thing. When I'm emitting, I have to use emit to respond to that, and I say my response comma data, or just decouple that. Don't assume that. But the idea is when I'm doing emit, so I'm sending, so my client is listening on this thing called my response. All my friends who are sitting on, all my friends has this socket io dot on calling my response in their end, and they are listening on data. So if I want to send on my on if I want to send the request on my response, I need to use emit. And so when I do the send, so this is like only one place it can go. This can go anywhere based on all the custom events. So you use emit here. And all we are doing is, as soon as some request comes in, we are just sending it back. Here we are sending it back to message, the default or reserved listener. Here we have listener default or reserved event. Here we have custom event. So we are sending it back to the client who has defined his own event calling my response like this. Now working with namespace. So here there are no namespace or default slash namespace, but let's say your client is listening on some namespace, or it has like, socket IO and comma namespace, and that is how it is listening. You have to send it back again on the namespace. If you don't specify namespace, your message will not reach to your client who is sitting on namespace. So like here, so if you define namespace here, and if you want this particular handler to catch the event or catch the data coming on this my event in your emit or in your send or emit, you have to specify the namespace equal to Python tut, otherwise it will not reach there. So namespace, which is giving the good idea about, so it's kind of a Reddit. You can create different chat rooms based on that. It's basically segregating different groups of people in different namespace. So not everyone is broadcasting on same place basically. And same here, either it is a namespace for default or custom. Now callback. So as I told you, you can do the callback. We saw the callback on received message. So when we are receiving, this is how we do callback. When we receive the message, and when someone send a message, if you want to call back on the send the message, you can do like this, like send the message and this callback, like message was received. So this is how we set up the callback on our, when we receive the message, on sending the message. So that is being supported. There's also something called broadcast. So what happens? So broadcast, this is all like we are sending it back to certain events and certain people, but broadcast is basically sent to everyone. In our chat use case, we basically want to send it to everyone. Like my 5 friends, as soon as message come to server, my server want to send that same message to all of my friends. So because of that, you have this broadcast. So in case of broadcast, you say emit, you say data and say broadcast equal to true, and everyone who is attached to this particular event, or everyone who is listening to my response event will basically receive the broadcast. And server as an originator. So this is like callback acknowledgement broadcast, where I receive the event, and when I receive something, I respond with this emit method. But let's say server want to initiate the message. This is not, this is independently server want to send something. So what you can do, you can just do socket.io send and emit, and just send the message. This is the use case when server is doing broadcast without without listening to something or without waiting for something. This is like server in itself initiating the connection and sending it to everyone. Broadcasting. This is like listen and then go back. Like I'm listening to my event. As soon as client send me something on my request, my event, I send it back. So I'm listening on my event. Client is listening on my response. So when I get something on my event, I send it back to my response to all the clients, and I do the broadcast. Here, I'm not waiting for anyone to come and tell me. I'm just doing the broadcast, basically. Now there is another concept called room. So like chat room, you can do the room, which is again the way to segregate your request. So when user comes in, they can join the room and they can leave the room. So this is another way to, so when you do join the room and when you do broadcast, it will be only broadcasted to particular room, because now you're providing this extra parameter in your send and emit, whether it's a send or emit. Now you're providing the room equal to room and then broadcast equal to true. So it will be only broadcasted to certain room that you are attached to and joined to. and then all the people who are like trying to connect to you, you can use those user and add them into the room using this thing called join room and room name, or they can leave the room on room name. So basically when client come to you, you can they can come to you on this join message or join request or join event, and as a client's request join event happen, that particular request or that particular user, you add them as a join, and when your client make this leave request, you can leave, let them leave from the room. So this is also another way to segregate and segregately broadcast your message is possible using the rooms. And again, like connection, so as soon as a client connects or disconnect with you, you can have this connect and disconnect event. So when someone just connect to you or make the connection request, you can do the connect, and you can like response, like if someone disconnect, your client can't talk to someone because they have disconnected, so you just drop disconnect. And if they are connected, you can say like when they come to you and connect, you can print the connect and you can send it back to yours saying that, hey, yes, I got you. Like ask your client, send your client another event or another message or another callback saying that, hey, you got connected. And again, on the connect, you can do authentication. Like if you want to do the authentication of the users, every time someone try to connect to you, it will just automatically come to your connect. You can authenticate the user, and if he is not authenticated using, let's say, authentication token or whatever, you can just throw them back saying that, hey, connection refused, you are not authorized to do this WebSocket communication here. I hope our setup is okay. This is pain. Let me. Okay, I think I need to deal with the. Okay, guys, let's go all terminal and try to code everything on terminal. So this is today's event. I'm going to use something called Atom. Atom is one of those tool or browser. You can use any of those event. So what we want to do first, we are creating the Python event. So first thing I want to do is create requirements.txt, and in the requirement.txt, this is the file where we actually write all our requirements. So let's write what you all need. So first thing, we need Flask, of course. Second thing, we need, because we are using Socket.io, Flask Socket.io. Second thing. Third thing, we need, so because it's a, so Flask has to have a couple of other, I would say, support for supporting WebSocket protocols, because default Flask only support default HTTP 1.0. So we are adding all these servers for the purpose of supporting. I think you don't need these two of them. I use them because I want to deploy on Gunicon, which is like like another kind of server, like Nginx, like Apache, like we did simple HTTP. Gunicor is another one which is widely used in industry for Python. So this is just for the purpose of that. Now, first thing first, we want to create our main file. So let's do main.py, and inside the main.py. So first thing we want to do is first, before everything else, we want to make sure that all our libraries and libraries are installed. And to do that, let's go back here and do pip install -r and requirement.txt. So this will install all the dependencies that we need. I think this is something to do with maybe VPN for my company. Okay, now you're talking. Just going back. I'm just so used to PyCharm. PyCharm or writing code traditionally? What do you guys say? Yes, no? Let's not use PyCharm this time around. Let's just go Atom. This is something new for me. This will be fun. I'm just so used to PyCharm because that is what I use in my day job. So my hands are way. Okay, something. sorry guys, I'm just not ready for doing it like this. I'm just going to use PyCharm because I'm just so used to it, and trying something new might take more time to fix things. Requirements.txt. I drop these things. I create a new Python file, name, install all the packages. Yes. And meanwhile that happens, what we're going to do is from Flask, import traditional Flask, and we'll be also, let's just start with the Flask. First thing, traditionally how we create the app in Flask, and give the name. So we'll be just going to give default name. So see if I can survey to, yes, okay. So hope the code is visible to you guys now. Okay, so here we are now. App dot, this is some just bare metal stuff that we have to do with the Flask, so bear with me. This is the all the housekeeping, you can say, or all the bare metal. So secret key, you can give anything. Let's say my secret, whatever. Okay, and then after that, so now this is done. Now by default, I would have started the Flask app, but because we are going to use Socket.io, what we're going to do is from Flask Socket.io, import Socket.io. So we're gonna create an app. Let's call it chat app equal to Socket.io. Now Socket.io will wrap around nicely to this Flask to add all the support that we need for web frame, for our WebSocket programming, and it's all like do all the housekeeping and overwriting all the methods and put up the wrapper around app method. So now our app is equipped to use the Socket.io, and few more things to start our server. So if name equal to underscore main, we run our chat app dot run, we call app, and I think debug is okay. Let's just do debug true for the purpose of debugging. Okay, nice. So this is our minimalistic setup, and this will, if we run the main app, basically to start our connection. So you can see that nothing is found because we haven't set it up anything yet, but basically our server is started and it's working. So now let's set up something very minimalistic. This is all typical Flask thing. So app dot route, R-O-U-T-E, route slash. So our it says that we're going to serve something on for our index, because so the thing is we need to first supply the client. So we need to supply the HTML page, which will at the end act as a client. So we need to do that first. So return hi. So I'm just doing return hi, so we know that things are working fine. So hi, so yeah, this is working. Now instead of hi, we actually want to return some kind of HTML page. So what we're gonna do is, so if you remember with the Flask, there is this idea that you have to create this folder called template. And this is the template folder where Flask will by default look for all the HTML files for rendering. Now create an HTML file, we will call it index. So this typical index.html file, and in the return side, we will do, so just need to import render. So for rendering HTML or rendering template, we need to import something called render template. And when we say return, we say return template, and in the return template, we're gonna type the name. We have the index.html. We'll just call it in body, we'll say chat app. Okay, nice. Doing that and going back. So okay, nice. So we are all set. So now we are sending the HTML page, and this HTML page will end up working as our client, and this is our server. So now actually get started with our WebSocket programming. So first, let's set up our server, and then we'll go for the client. So for setting up server, let's first handle the do the connect. So what we do for the connects. So first thing, we start with our chat app. So chat app is as I told you, like this is what we are starting here. So we're gonna start with the connect. So as you remember, it's the reserved keyword connect, and this will be triggered, or this server event will happen every time a new client will try to connect with the server after TCP handshake is done. And that's for the purpose at the namespace, and this namespace we're going to call chat. So now again we need to set up the method, so we will call it handle connect. So handle connect will handle the server event, which is basically a client is trying to connect to the server, or yes, basically trying to connect to server. So from the server side, we're gonna print a client connection, a client connection requested. Basically, it is like client connection because we have already accepted the connection, so it is not just pure requested; it's already accepted. And and we also want to send the response to the client saying that. So we don't need that. We just need to do the emit saying that you are connected. Sorry. So here we're going to say that my response. So now my response, I have not set up this event yet, but I'm going to call it my response. This is the event which we're going to set up on the client side. So that we will do. And response with data. So we're going to send a JSON doc, and we're going to say data, and data will be a string. It says that you are connected. And we're going to send, and again, like we need to set up the namespace because as I told you, so we're gonna hang on to this particular namespace. So from the client side also, we'll set up this namespace there. Okay, so this is a connect. Now this is the minimalistic thing that we can set up here. And we need to now go to our client. So what we're gonna do is, so our web browser will be our client, and we're gonna use a JavaScript library called Socket.io for our client. So let's do that. Now for this, first thing first, we need to import those, jQuery and Socket.io. So let me search online jQuery CDN, jQuery link. So this is nice to like get the jQuery. Let's get jQuery 1.12. This is all, I think, latest ones. There is the code.jQuery. Let me look. Okay, this will also do jQuery 1. The latest one. Okay, whatever. This will do. So either you can do jQuery or jQuery mean, doesn't matter. Script, you want to import this script and script. Inside the script, src equal to this jQuery link, and we will be, I think this will be enough, yeah. And finally, we need Socket.io. So script src equal to something. We'll look into online for finding the Socket.io. So we're gonna go and look for CDN Socket.io. So CDN is content delivery network. Basically, it gives you like, so you can basically your internet, your browser will directly download all these things. So any of that, we need actual Socket.io. So this is one that we want to copy. There are different versions of Socket.io, but let's just go with the classic one that has everything. Okay, nice. So first thing, we are set with the required library dependencies. Now let's, so we want to make the request. So making the request, now we need to write a small app. Now I know this is a Python meetup, and last thing you want to see is JavaScript coding. So but bear with me. This is how we have to do it because this will be much more interesting than writing the client in Python. So text JavaScript. Here we have. Now first thing I want to do is where socket equal to io dot socket, and then we want to provide the path for. So this is where we start our server here, and we want to set up where we want to look into. So this is our HTTP ::, and to like because we'll be running different kind of, so your URI might change, localhost 127 or some custom if you're deployed. So what you're going to do is something called document.domain. So document.domain will give us our domain name, whatever it is, just to pick it up from your browser, make it easy. And now we need port. So again, the same thing with the port also, that we can fetch the port using location.port. So these are all classical HTML stuff, JavaScript stuff that port. And finally, now as you remember that we are creating this namespace, so we're gonna call it chat. So it's gonna be like whatever domain names, let's chat. This is our basically server. So this is how we define the server. On the client side, we are basically setting up the WebSocket connection set. Now, what you want to do? So first thing, socket dot on. Remember connect. So we did something on the. So this is something that will happen here also, and this is something that will happen on server side also. I know that we are running a little bit late, but I want to, before I go and spend a lot of time, probably till 8:30, I just want to showcase that at the end, how the app gonna look like. So this is a demo. This is the code that I have already written, and this is something that we'll be writing actively right now. I'm setting this code right now. You guys can open this whole link and you can see the live message. So I'm going to do the inspect here, and we're gonna observe the message that are being sent and responded. So please open up this link. And if you can also either look at my screen or you can look at your screen and observe the whole connection that happens here starting. So the coding part I will continue slightly later, but first I want to showcase how at the end the app will look like and what we are going to do here. So this is our HTML page, and we're gonna see whole transaction. So when you do this HTML request, so first thing, this is our HTML request, where we are asking for, so this is our default request, this is our URL, get request, okay, and everything. And then right, I'm looking for the WebSocket request. So this is our WebSocket request. So if you can see here, this WebSocket request should be somewhere lying around here, but this one. So this is the WebSocket request. So what happens when you establish HTTP connection, then you say that, hey, I want to upgrade my protocol from HTTP to WebSocket. So this is the request where you are requesting WebSocket, and like you're trying to say that, hey, I want to upgrade my protocol. And when your server agreed, so you can see the status code 101 switching protocol, which says that, hey, we are upgrading on new protocol, which will be socket. And you can see the response header, which says that, hey, this is the upgrade. And now we are switching back to WebSocket here. And the connection is upgrade. And then you can see cache control, no cache, because you can't do caching in WebSocket. And then upgrade to WebSocket. Query saying WebSocket. This is socket ID. So this is like my client ID, you can say in a way that, or some kind of session ID or something from my side, which tells server, hey, server will remember me with this SID and things like that. So this is how your normal HTML connection is upgrade to socket message. And then we can go and see the message here. So you can see that when I started from the server side and from the client side. So you can see this is like coming from the client side, user connected, data connected, user connected. Now let's type something at the handle, I will say this, and then I say hello, and I say submit. So when you see here, so message event, so here message event happens. So message event is the event that I'm setting on the server side. So when I do this, this particular message event will happen. My socket query will send the socket message to the server saying that this is my event and this is my data, and it will finally go there. And then server will respond me back, and whatever server responds me back, I'm putting it here. And that's how the connection connects. All of you who are right now online, please like just try this out. This is live. This is like every time someone gonna type something, it's gonna go to server, it's gonna come back here, and it's gonna be on everyone's screen. So this is live web chatting. All we are doing is our WebSockets are sending data back and forth. Our Python server. So when anyone types something, message something, it's go to our Python server, and Python server broadcast that message to all of us, and it comes to the client or a browser, and our browser, which has this socket IO code, it will grab to that message, and once it grab to that message, it's basically just append on your browser. So this is all appending happening on your HTML thing. So this is the live example. If you want to add a database and all this kind of stuff, so you can go crazy on all these things, and try to perceive this data, because as soon as I will refresh as soon as I will refresh my page, it will all gone, because I'm not storing data anywhere. I'm just whatever data coming in from server, I'm just appending it on my web page. So when I refresh my web page, everything is gone, and it will start appending again. So in that sense, like if you want to add the database, you can add the database. This is how when you are on the chat messages, you get this kind of like you get this kind of like message, or this kind of like update, and this is how the broadcast happens basically. You can see that this is collaboration, right? This is I open up my Google Doc, you guys open up your Google Doc, and right now we are seeing each other's comments and message in the real time on everyone's page, what everyone else is doing. So this is all possible with the WebSocket that we can achieve here. Now, for those people who want to stick around and look at the code, I will continue my presentation typing the code back, and all this code will be available. All this presentation will be available. I will send an email sending all the links, or otherwise by default it will always land on our default GitHub page, where we put all our content from all our meetups and all our video messages. So okay, so this is what we're gonna do. This is what we are trying to achieve. This is what we're gonna deploy, or this we want to build. So let's go back and start and keep building this whole thing from scratch. So here, this is so on the connect, what we're gonna do. So basically, on the connect, you want to send something to the server. So what we're gonna do here, socket dot emit, and what we're gonna emit. We're gonna where we're gonna emit. So first thing, before we start emitting, we need to have some kind of socket connection there. So let's add this one. Let's go and create one more event here, because connect is one event, and if we debug this whole thing, and if let's start the main, and right now we only have connect. So I'm coming in here, and if you see here, there's a connection here, and let's try to inspect. So we haven't written the whole thing yet, so it is like saying the error message, but we're gonna keep building on top of this. So okay, so now let's create the server event. This server event will basically be responsible for distributing the messages. So chat app dot on, and then we call it what are you gonna call it? Message event, MESSAG message event. So this is a message event that we are creating, and again, not to forget namespace, because we're gonna keep everything on the same namespace, chat. So what should happen when someone come to me? I should basically, when someone send me some message to distribute, so this method gonna distribute that message. So whenever I receive the request from anyone on message event, I want to distribute them. Let's just first write the handle for this. So handle message, and for this, what we need is basically data, and so let's just first print whatever is coming from the client side. So I need message plus we'll just convert to str because I don't know in what format it is coming in. I don't want to break this thing. And when I receive the message, what I want to do is I just want to emit it message back to everyone. So everyone will be listening on my response. And this is broadcast basically. Just if you saw that emit dot response dot emit, where we say going back to presentation, if you have, this will be data, and finally namespace, because we need namespace called chat. And one last thing, that will be our, do we need acknowledgement? Okay, let's just yes, send the callback. Equal to ACK. So let's define our callback. What our acknowledgement gonna look like? It's gonna be ACK, and it will basically just print. So it was received. Okay. Okay. So we have set up this, and whenever someone comes to us, we will just emit it back. We will just broadcast it back to all the clients who are signing up on my, who are listening on my response. So first thing, we need to send the data to the server before server send it back to all the other people. So from our side, we need to first create an avenue where people can send the data. So how are we going to do that? So basically, we will just create a small form here. Let's just do some, so form. So this is the place where the client will write the data that it want to broadcast to the server, broadcast to all the other people. So xn equal to default, because you're gonna look, going back to same method equal to post. Normally post is because we are creating something, it should be done by the post. This is some standard idea that we need to carry forward, because it's a post, and post, when you're creating something, it always has to be post. First we want is a text box, so type equal to text. This text box will be about username or handle, whatever you want to call it. We're going to call it username here. Class is username, and placeholder just to tell that, hey, this is where you need to type the username. So I'm going to call it handle. And second thing that we need is that another text box where we actually type the message. So let me just, okay. So type equal to text, and class equal to, so we're going to call it message, and placeholder again going to be some fancy funny post. Okay, so now we need this text box, sorry, this submit box. So this will complete our form, or complete our way to like submit something that we want to, that where we can type and send for everyone to see. Now that we have this here, now look at here. So what happens when someone click on submit? We're going to capture that, and we're going to capture handles, we're going to capture this text, this fancy text box, whatever you have written, and send it back through jQuery. So we are not actually, I wrote the post, but we are not actually going to use the post. We are actually going to just intervene, prevent the default behavior, and capture the data, and just use jQuery to do all this kind of magic. Just capture the text from that text box and send it through our WebSocket message, basically, instead of standard HTTP. So here, what we're going to do on the connect, we want to do emit, and remember where you want to emit. You want to emit or you want to send on this message event. So on connect socket.emit to message event, and then we want to send the data. So what data gonna be? What we're sending is basically telling them user connected. Okay. So this is first thing. Now, second thing is first we send them user connected. Second thing, we want to capture those content from those text box and then send it. So for that, let's use jQuery magic and try to capture those data. So first thing we want to we want to first capture that element. So how we go about that? So first thing we want to capture this through form. So this is the jQuery syntax. So we are looking for this element called form in our HTML, and inside that form on the event of submit. So this is jQuery event, not to like confuse with our socket event. This is jQuery event. When you do submit, basically on the submit, this is the function that has to operate. So basically when you click on submit, we basically want to send the data using WebSocket and not the actual one. So when you click on submit, first thing first, we want to prevent the default behavior. So for E or for element or for this element, we want to prevent default. Yes, here. So you want to do prevent the default. So don't submit and make the default HTML post request. Now, second thing, you want to capture the data. So let's capture the data. Let user name equal to is jQuery used. Couple of places still use jQuery in production. So yeah, it is possible. And some people still use that, but I think those people who are already on Angular or React JS, they don't use that because Angular JS, they do the job already better. You don't need to do that. So now we want to first, from that input box, you want to take the username using this class selector. So this is a selector as we call it. So we are selecting this particular element and then capturing the value that is sitting inside that. So username will capture first value, and second, you want to capture user post or user input. So user input that you want to capture second thing. So same thing, we want to capture this. So these two variables from input dot we had name message for the message class and dot well. So now here, sorry. So now we have taken those two content of those two text box. Now what we want to do, basically now we have data. Now we want to send it using our socket. So how to do that? Same thing, socket dot emit, and emit first thing on which event. So the event will be our server event is a message event. So on the message event, what all we're going to do, first thing we're going to send the data. So let's send the data. It's going to be JSON data. So username is our text, and username, basically just a dictionary, and user input, which is going to be basically user input. Let's call it message. It will be much more clear. Okay. So now that we have these two contents, so this is what something that we want to send when like you send the message. Now next thing, we also want to clear out our basically you are already sent a message. You want to every time you type something, you send, and when you send, you want to clear the text box so it become empty. So we're gonna do the same magic using jQuery. jQuery, we're gonna pick that input dot message, and we're gonna like clear the whole thing. So input dot message, and then we're gonna set the val as an empty, so clear out the message that already being sent. And then dot focus will basically like bring your focus or bring your tab or bring your cursor or bring your whatever to that text box. So this is the focus. Now with this, so as far as, so right now what we are doing is just sending it to the server. We are not getting it back, so we're just gonna look at the log and we're gonna see that message reaching to the server now. So let's so page has been refreshed. Let's open up the page again. So you're gonna see this thing here, handle and fancy. Let's open the inspect. So and network, and just refresh once more so we can have that. So this is our connection, and now let's do handle, let's say this and say hi. When I say submit, so it says method not allowed post. So do I what I missed? Do I have to do any kind of let's see at the server side what it says. Says I think something is wrong from the side where how he's sending the text. M8 user. This is okay. This is chat. This is chat. This is chat. This is chat. Um, Connect is okay. Render is okay. Text is. There's something wrong from the client side. That's why I hate it. All this socket mess. I hope I resolved. jQuery is okay. Socket is okay. Script is okay. We are setting up HTTP connections, not HTTPS. Domain is fine. Port is fine. Slash chat is okay. I don't know semicolon how much important it is here. Method is still not allowed. Socket, IO.socket, HTTP, meet user.form on submit, functionally prevent default. This all looks okay. We are sending on, emitting on message event. Ah, still issue. So it's Websocket IO.connect, HTTP, document.domain, location.port, slash chat. Sorry guys, I where on connect function socket.emit message event data user connected. This is over. Creating form, picking up form. On submit, you're calling this function. Prevent default username, picking this socket.emit message event, username, user input, and then cleaning up the whole thing. It's wrong.
Connection got accepted. Chat app patron. Secret socket.io. It basically did the post, so basically it didn't act properly here. Username, message, text tag, this is all look okay. Is the jQuery working okay? It has to. Okay, I think I have a code. I'm just gonna copy paste some of this use HTML code. I don't know what went wrong, and I don't want to hold you guys for longer. My uh, so what I'm trying to do right now is just copy pasting the code. Namespace. Yes, I think that could be the issue because I'm not specifying any of the namespace here. Let's try this. I think that was it. Yes, namespace are always crazy. Thank you, Joey. So client is connected. So okay, we are going somewhere. Now let's go back and like try to complete our app. So basically what we did so far is we are able to send the message. Now the message is coming back and we want to print the message. So if we look at our this socket message here, so user connection was established. Let's try hi. So this message is coming and like this message has been going. So we need to like print this message back on our web browser. So how are we going to do that? So so now that we have this, we need to like create another socket message which basically will be like listener. And once the message comes in, because if you see here, client is sending the message on my response, and we need to set up the my response on our client side. So right now this is all socket on connect. So let's set up socket on my response. This is something that will be taken care by UI when server send back the data to the UI. So same drill function, and the message is coming in. So message, we want to process that message. So what we're going to do basically here, we want to take this message and append somewhere. So let's create some kind of element here. So this element will be the element where we'll be appending this message that is coming in. So let's create a placeholder here, class equal to message holder. Okay, so this is the message holder. So this is like an empty element which will take all the data. So that is coming from server. So when server send back something on my response, we want to like pick that element and append the content. So let's code that. So first thing, we want to pick the element. So if let's do sanity check later. First start with the tag. So we want to pick div selector, div dot message folder, because that is a class. And now dot append what you want to append basically. So here we're going to append our HTML content. So we'll just do like another div and div, and in between that the message. So what message coming in? So it will be msg dot user underscore name. The same content that we sent will come back to us again. So plus, let's say colon, and let's say another plus, and let's say msg dot message. So this is something that we are sending to server. Server is sending the whole thing, the same thing back to all the other clients. So those other clients who will be listening on will receive this format that is being sent to server, and server is just forwarding them to everyone else. So when server sends this message, so we'll be actually listening on this my response. When message comes in, we want to append this whole message into our whatever that we have created there. Okay, nice. So MSC, right? Okay, cool. Okay, so let's go back, and I think this will work. Restart the whole thing. Okay, so this is trouble. What happened? We are inside the function, right? So this is the function dot append. Okay, anyways, let's go with this. Hi. Can you send this in the memory? This one. Message event. So let's see whether there is some handle message has some error. Handle message, there is the data. What else you need? I'm gonna try something weird, but let's see if this works. Okay, I guess not. There is a server event, message is being passed. Message handler takes one argument, two are given. Message event and namespace. Sorry guys for all this like trouble. Like this has to be resolved well before. Data is going to server, but server is I think not able to send it back to the client. Uh, so here I'm doing chat emit. This is the event JSON namespace and callback. What am I missing? Says that handle takes one argument, two are given. No mess. This is decorator. This is something we need. Handle connector is working fine. Guys, it's really too late. I'll send you the code so you guys can write down and practice by yourself. Sorry for this trouble and uh, this should have not been done just like this. Okay, guys, I want to close the call now because it's already too late for everyone, all of us. I will send you the code. You can try by yourself, and hopefully, all the knowledge was uh, helpful for you guys. I'll catch you again later soon. Stay tuned. Keep posting. Keep in touch to our meetup group. We have Slack channel too. If you wanna try, learn, do something new, we will be there. Where you can get the code. So you will get the code in our. We have this GitHub repository where we post all our meetup code. This will also land there. Where you can find it, you can go to our meetup page, and there is like on our description, meetup description. There is a link to that and link to everything. And again, I will send an email which will have the link to GitHub repo and where you can, um, which you can use that for your purpose and like look at the code, look at the video and everything else. Okay. Thank you guys.